3.
For our physics project, we are focusing on the physics of tennis.
We are focusing on impulse and momentum and Newton's 3 laws,
Kinetic energy and work.
Newton's 3 laws state that every object in motion tends to remain in the state of motion unless an external force is applied to it, and they're shown. Number 2, the relationship between an object's mass and its acceleration and the applied force is force equals mass times acceleration. The object with greater mass will experience less acceleration, and the object with less mass will experience greater acceleration. For every action, there is an equal and opposite reaction of the same magnitude and in the opposite direction. These 3 laws apply to physics because Newton's first law relates to the motion of objects. In tennis, a ball would stay at rest unless the racket comes in contact with it, which propels it into a state of motion. As a tennis player serves a ball at rest, they put the ball in play and also exert a force onto the ball, which puts it in motion. The ball would stay in motion if the force of air resistance did not slow it down, if the tennis court was not in the way, or if the opposing player did not apply another force and return the ball. Newton's second law defines force in terms of mass and acceleration. As the racket hits the ball, 2 things happen. The ball accelerates and the head of the racket decelerates. If the racket was heavier, it would take more force to accelerate the ball than if you were using a lighter racket. Newton's third law discusses action and reaction forces. When the racket hits the ball also exerts a force on the racket. The racket experiences the same amount of force that was applied to the ball, but in opposite direction.
The momentum before the tennis ball and the racket collide in an elastic collision is not the same as the momentum after the collision because an impulse occurred, which resulted in a change in velocity of the ball. The impulse in this situation would be the racket making contact with the tennis ball. The racket applies a force on the ball for a short period of time, resulting in a change in velocity. The average time that a tennis ball stays in contact with the tennis racket is 10 milliseconds. So if you plug in that time into the impulse equation, impulse equals force times the change in time along with the velocity of the ball, you can find the force of the impulse. In the absence of an impulse, the mass of the ball times the velocity before the collision equals the mass of the ball times the velocity after the collision. Impulse is something that changes the momentum of an object. Impulse equals the change in momentum, or the force times the change in time. Momentum is the mass times the velocity. Momentum is a change in velocity as a result of a force over time.
Work is force times displacement. Work is done when a force acting on a body displaces it. When hitting the tennis ball with the racket, work is done. Work occurs after an impulse is applied.
and this is the physics of tennis.
For our physics project, we're focusing on the tennis of physics.